evaluate the integral above by taking the derivative of each answer to see which one matches here. So the textbook's trying to get us to start with antiderivatives. All an antiderivative is it's something whose derivative can be the original function that you're given. So if one of these is the antiderivative of this function, we should be able to take a derivative and it should turn into this. Okay. So taking a derivative term by term, we know that we need to use, so the derivative of an exponential function base e is itself. So we'll start with that. But we know we need to use the chain rule because there's an innermost function. There's this function up here. And so the derivative of 8x squared, that's 16x. And then that's it. We're done with the derivative of this term. Now we need to take a derivative of this term. But the derivative of a constant, something that's not of our variable, that's just 0. So when we clean this up, this is 160x e to the 8x squared. Right? So that's not this derivative of, that's not this this original function. This is not the antiderivative. When we took a derivative, it didn't turn back into this. So we'll do the same thing here. We'll take a derivative of this. If it turns into this, then we found our antiderivative. So this one's more complicated. We need the product rule, right? Because this is a function of x and this is a function of x. So we take a derivative of the first function times the second function kept the same, plus the first function kept the same, times the derivative of the second function, which we just did, right? The derivative of e 8x squared is e 8x squared times 16x. And so this is clearly not going to turn back in here when we clean things up and collect like terms, because we're going to have this term left over, 5e to the 8x squared, and there's nothing that matches up there. So this isn't our antiderivative. So term by term here, the derivative of an exponential function is itself, but then you've got to use the chain rule. So this is 64x squared. The derivative of the constant c is 0. Oh, sorry, we're not done with this. So the derivative of the innermost function is 128x. So if you do 5 times 128, that doesn't make 80. So this also is not the antiderivative. So this final one, when you take a derivative of an exponential function base e, it's itself, but then you've got to apply the chain rule. So the derivative of the innermost function is 16x, because the derivative of 8x squared is 16x. And again, the constant's gone, because when you take a derivative with respect to x, this doesn't involve x at all. So that's 80x e to the 8x squared. This is our antiderivative, because when we take a derivative, it turns into this. Same thing here. We want to take a derivative of each term to see if it turns back into this. And if that is true, we have found the antiderivative. So these ones need product rule. All of these are going to, well, except for this one. This is a function of x, and this is a different function of x. So we take a derivative of the first function, that's 21x squared, times the second function kept the same, plus the first function kept the same, times the derivative of the second function. The derivative of natural log of 3x is 1 over 3x, and then chain rule. The derivative of the innermost function of 3x is 3. So that cleans up to be 1 over x. And then when we keep cleaning it up, you've got 7x to the third times 1 over x. That makes 7x squared for this term. I went out of order here. And then this term, there's nothing we can clean up. That's 21x squared natural log 3x. So this term and this term don't match with their coefficients, so it's definitely not going to be it. And plus, we had it. This term is going to be 7x squared, not 7x. So this isn't our antiderivative. So here I'm going to stop writing the d dx, but I'm taking the derivative with respect to x. So I need the product rule. The derivative of the first term, 14x, times the second term kept the same, plus the first term kept the same, times the derivative of the second term. So when we took a derivative of natural log 3x up there, it was 1 over 3x times 3. So the 3's cancel out. So the derivative of natural log 3x is 1 over x. And then when you clean that up a bit, this term stays, the first term in our derivative stays the same because there's nothing that can combine or simplify. But over here on the right, x squared and 1 over x, one of the x's can cancel out to leave us with 7x. So this is the same thing. The order of addition doesn't matter, so we should be able to swap that 7x. So we found our antiderivative. It's this one.